All right. This is it. We started. Okay. Thanks, guys. So today we're gonna there's a few little safety considerations we need to think about today. So like I'm wearing eye protection, okay, because we're gonna be looking at some pretty bright lights. So these are kind of the goggles that they use, the old time goggles that we would wear for welding. Like I wouldn't do welding, but you can see how it stops a lot of the light coming in. I just want to make sure that we're here. Everybody's being safe during viral lockdown, and we're doing light science today. And remember, a lot of these things will be, all these things you're going to be able to see. If you want to go back and have a look at them, I'm just going to show you a little outline today. All right, so we've got, we're looking at light, and light is a form of energy, sources of light. Looking at Uinuku is our god of rainbows, Roy G. Biv. And then there's three kind of topics that, you know, you kind of can think about, hopefully you get at the end of this. There's reflect, refract, and absorb. Okay, so this is what light does. So when you think about light, it's either reflecting, absorbing, or refracting. So those are the three things we're going to think about. So I'm just going to show you refracting. So these are kind of little experiments that you can look at. When you look at this, I put a chopstick in there. And when you look at the chopstick, that's a good little, it's hard to focus on this. But how it's bent, it looks like it goes straight, and then it kind of chicks like a little lightning bolt over to the side. You can look at that. So that's bending. So if you can do this with a spoon or kind of anything in a big glass. So that's light bending. As it goes through the air, it does one thing, and as it goes through the water, it does another thing. Okay. So there's reflecting. So I'll show you another picture of what reflecting is. I like to use these pictures. This is good with the apple. So when you look at the apple, okay, so the main source of light is the sun. Okay, that's what we're looking at. Actually, don't look at the sun. And this is like reflecting, is like a mirror. Transparent or translucent is when light passes through something. And then this is reflecting. Okay, so when something is red, it's absorbing all the other colors of the rainbow and reflecting the color that you see. All right, so we'll go back to this one as far as all right. So we're looking at colors. So these are all the colors. So there's lots of different obviously lots of different kinds of colors. So these are reflecting, like blue is reflecting blue light, green is reflecting green light type thing, and white is the most reflective of all, because white reflects all the colors, which we'll look at, and then black absorbs all the colors. So absorbs is like a sponge when it sucks in and doesn't reflect. So that's the rainbow. So when you look at it kind of a rainbow, so this is refracting. So you get the white light that comes in, and then it bends it and splits it into different colors. So that's the rainbow effect, which is pretty cool. And here's just another of these little pictures kind of help it along. So this one, you can see how the white surface reflects all the colors, and the black one absorbs all the colors, and say a red surface will just reflect whatever the surface is, whatever the color is, it's reflecting that one and absorbing the other ones. All right, hopefully that will help you. And because I do a lot of this work in schools, and so it is pretty good. It's important to know kind of Uinuku is the colors in Te Reo Māori. So we look at ma whero, karaka, kowhai, kakariki, kikorangi, waiporoporo, parauri, and pango. So some of you guys may know this. If you don't know this, it's just good to know, get an idea of what they look like and sound like. Te Reo. That's what I like. Oops. Sharing has stopped. We'll go back to this one. All right, so now I'm gonna show you a couple little experiments. Okay. I'll just show you some of these lights. Okay, so these LEDs are pretty good. This one's like a really, really strong LED. So I'm going to shine it straight at the light, at the camera. All right, so the technology involved in these is huge these days. So the LEDs, they use less power and they're brighter. And I remember all the light comes from the sun. If you don't look at the sun, but if you want to look at the sun, I've got these goggles that allow me to look at the sun. So these are Eclipse glasses. So these were specially designed for solar viewing. These have seen some better days, but these are the ones you can get these online if there's eclipse coming, or sometimes if you look through a telescope and you can put those on a telescope. I can put these. I'll show you these through the lens. I'm not sure if you can see much. No, they're really, really dark. All right. Another thing that I've got. I've done a few light Nelson projects. So we're in Nelson, New Zealand, and a lot of these LED strip lights are so cool. Like I did a DNA model last year at the gardens, in the Queen's Gardens. Sadly, this Light Nelson project, it happens in the winter, has been canceled this year in Nelson, but we're going to come back and do it again next year in 2021. And what I do a lot of community engagement with kids and stuff. If you come along to Light Nelson next year, you'll be able to help me make a little light sculpture. That's kind of the things that I do. So then reflecting, refracting, and absorb. So absorb is when it sucks in the light and doesn't reflect it. Reflecting is when it bounces back. And reflecting is like a mirror. So I'm going to show you this one. That's what I've got. This is my little experiment of the day. So I've got a pretty serious laser. Okay. This laser is going to pop the balloon. All right, I'll come over here because there's more light on this side. All right, so when I focus this laser onto the white, nothing's going to happen. But when it moves from the white to the black, because black absorbs, so white reflects, black absorbs. So it's going to absorb the light energy from the laser, and it's going to pop the balloon. And I have some cool. These are, because the laser is so powerful, we use red goggles. So when you put this, so the red, I can put that over here. Let me do this. All right, so that turns everything red and a little bit fuzzy. Okay. So this is just because lasers can be a little dangerous. So I'm just wearing these red goggles because this is a red laser, and then we'll have a go and see if this works. All right. So I'm gonna focus this. Oops. I just gotta get. Oh, here we go. Again, these obviously needs a battery. Somebody forgot to put the battery in. Here we go. Oops. All right, here we go. So I'm gonna the laser on the white. Okay, this is a serious laser. So I'm focusing it on the white, and now I'm going to move it over to the black. Oh, okay. All right, so you can see how this is a mighty laser. So this is not like those little $2 shop lasers that you have. This one, I'm shine it behind me because you don't want to look. Here we go, that one. Is very powerful, and you don't want to shine that in your eyes because it would be quite dangerous. Okay, so that's one of the things. We'll go back and have a look at what that's it. That's just a little starter on on light. Oh yeah, we tried to do this. If you want to do this little refraction experiment, you can see this with the glass. All right, so you can do that with anything. That's something you can do at your home. And remember that the light travels through air differently than it travels through water, and different liquids actually. Oh, you know what? I was going to show you something else. So this was rainbow. What we looked at today. Light is a source of energy. I want to show you one more thing. I'll come back to this. Oops. All right, here's another little experiment that I like to do. All right, so when I've got, tilt this down so you can see it. Bring it a little closer. So when you shine a laser through the water, you can kind of see it reflecting on the glass and stuff like that, and it actually is going through the water. But this is so you can see the laser. I just put a little bit of milk. I'm just going to put just to cloud the water just a little bit so you can see the laser beam. And then hopefully when you shine this through, so that lets you see the laser kind of cruising through the milk, so you can see the laser. Oh yeah, there we go. So you can see the laser light. If you even, this is a really good experiment. If you have one of those like $2 shop lasers, and you can actually see the laser in the milk in the water. Okay, so again, thanks for coming, guys. It was good to see you guys, and we will have a nice Easter and see you tomorrow. All right. Let me go to this one. Thank you. Oops. See you guys.